Good day to all. Today we can discuss the topic about how the finite element method works. Here, before going into how the finite element method is working, we should aware what is meant by finite element method. So, finite element method is a numerical technique which can be utilized by partial differential equations for getting the solutions. The solutions means assembly of finite elements. Already we know about finite element method always follows the discretization procedure. In previous video also I explained about how can we discretize the component in volumetric manner. So the finite element method used to solve the engineering problems by describing the component or element with the partial differential equation for representing with the finite elements, which is the meaning of finite element method. So generally engineering problem classified it into two types, which are the structural problem or fluidics problem. The fluidics problem, there is a thermal fluid mechanics concept available. In structural problem, machine building, structural building, all the problems are available. So these problems can be solved by two methods, which are Lagrangian concept and Eulerian concept. Here I have one question. What is Lagrangian concept? In space, all the things are available as a particle. So all objects are consist of particles. So the particles can be moved freely on the space. So during the particle movement, the particle retains its identity, which means the particle has its own density, own specific volume, own things within the system. So it retains its identity during the particle movement. And then the position of particle in space we can study with the coordinate system. From that coordinate system we can identify the location of and the position of the particle in space with the function of time. These are all the concepts are followed by Lagrangian concept. In other hand, we follow Eulerian concept. Eulerian concept also available in engineering problem solving method, but the Eulerian concept always follows continuum. Okay, here I can represent the continuum model with my slide. Here you may identify what is meant by continuum. Continuum rather than containing of particle. The continuum study is not with the particles, but which can be studied through the object structure. So in that there are lot of field quantities are available. For example, if you are considered the particle movement means there is force, displacement, velocity, likewise lot of field quantities are available. These field quantities can be studied through focusing on any one of the point from the total domain space. From that one point we can understand the entire domain or entire space that are available with the object for analyzing. And then if I want to analyze some system, some object means what are all the steps I followed as an engineer. Okay, so all engineering problems are represented with the boundary conditions. So now I have some doubt about what is boundary. Here you see the piston and the cylinder available. Inside of cylinder there is system available. So the piston and the cylinder are closed with each other, so that I can get the closed boundary for the volume area, volume of cylinder. But if I consider any small hole available with this cylinder means the system opens. What happens with the two conditions? One condition is boundary open, another condition is boundary closed. If I consider the boundary open means the system may consist of infinity region, but if the boundary is closed means the boundary has some confined region. In that region I can study the particle everywhere. But if I open the boundary means I can fix the limits. I can't fix the limit, which are because the space is infinitive. Which are all the things available with the boundary condition. We as an engineer we can consider both the condition for the respective problems. So solution for engineering problems can be arrived from approximate solution or exact solution. So the solution also classified it into two types, which are approximate solution or exact solution. What is mean by approximation and what is mean by exact solution? Let's see. Yes, first I want to tell you about exact solution. The exact solution in engineering problems are exactly satisfy the governing equation. What is governing equation? In previous video I explained about the F is equal to ma equation, and that how can we formulate the governing equation, so that in exact solution method the problem satisfies the governing equation formulation and it satisfies all the boundary conditions, which may be open, which may be closed. Likewise, which can give the solution to the provider, I mean requirement person as a engineer, which means exact solution. So in exact solution, both the conditions to be satisfied, which are governing equation and boundary condition. But approximation solution also available in engineering. So approximate solution in engineering problems are exactly satisfies the governing equation but not satisfies all boundary conditions. So approximate solution only concentrated about governing equation but not the boundary condition. It may be open but it may be closed. It does not satisfy the boundary condition, which is the procedure available with the approximate solution. So now you may aware about what is meant by exact solution and what is meant by approximate solution. Now we can move to another thing, which is important features that are available with the finite element method. Here two important features are available, which are, first one is piecewise approximation, second one is locality of approximation. Here what is meant by piecewise approximation? Piecewise approximation always delivers the good precision through increasing number of elements. But as an engineer, we may consider about locality of approximation. What is local approximation? Piecewise approximation may give the good precision results, but in local approximation what happens? It produces tiny equation. It develops easiness to solve problems with a large number of nodal unknowns. So it rectifies that some problems that are available from the piecewise approximation. Which are all the steps that are available with the finite element methodology working procedure? So we should aware what is meant by exact solution, what is meant by approximate solution, and what is meant by piecewise approximation, and what is meant by locality of approximation. And finally we come to the point, which is how to finite element method work, which follows 6 general steps, which are, first, discretization. So in engineering problem we follow the continuum method. So discretize the continuum is the first step, and the second step, how can we interpolate the elements with each other? Yes, select interpolation functions is also one of the steps available with the finite element method work. And the third step is find the element properties, and then fourth step is assemble the element equations, and the fifth, solve the global equation system, and then finally compute additional results. I can explain one by one. First step, discretize the continuum. The first step in finite element methodology working is discretize the continuum, which means split a solution region as like this rectangular portion. So from this rectangular region we can split it into n number of parts. That n number of parts is known as finite elements. So in that I can select only one element, which is known as finite element. The finite element mesh is normally generated by a pre-processor program that is available with the ANSYS software and any other analysis softwares. The details of mesh consist of nodal coordinates and element connectivities. Here you see element connectivity as a rose color available, and nodal coordinates is also available with this blue color available with this image. And then second step, select interpolation functions. Generally the finite element methodology follows polynomial interpolation function. What is meant by polynomial interpolation function? Polynomial equation is a sum of constants and variables. Here you see u1 and u2 available. Here the point interpolated from u1 to u2. So here I utilize some u and u2, which are all the variables, and also u1 has some constants, which is 1 and 2. I may assume both the things. So interpolation functions are utilized to interpolate the field variables as like density, viscosity, displacement. Those are all field variables. I may interpolate that field variables over the element during the analysis. So by the utilization of polynomial equation, I can interpolate. Often polynomials are selected as interpolation functions. The degree of the polynomial depends on the number of nodes assigned to the element. And differentiation and integration of polynomials are simple, and the accuracy of the results can be maximized by increasing the order of the polynomial, which may be dou square u by dou x square plus dou square u by dou y square plus dou square u by dou y square. Likewise, I can add the polynomial orders as like second order, third order, fourth order. Likewise, I can increase the order also. Similarly, these reduces the computation difficulties also. So the second step is interpolation functions that are considered for our finite element methodology work. And then third step is find the element properties. What are the properties? Yes, the matrix equation for the finite element should be established, which relates the nodal values of the unknown function to the other parameters. For example, if you are consider the stress strain curve, the unknown parameters as a displacement also one of the factor that is indirectly impacted on the process. So which also important in analysis. What are all the other factors that are influencing on the process, and then assemble the element equations. Finally, I can frame the equations for each and every individual element. I may assemble all the element equation with each other. So from this assembly, I can find the global solution of the system. So to find the global equation system for the whole solution region, we must assemble all the element equations. As like this diagram, there is circle available. It's splitted as a simple triangular elements as like x, y, z. So x has its individual equation, y has its own individual equation, and z has its own individual equation. So finally, we combine these three local equations, we can get the global equation, which is the assemble the element equation step that is available with the finite element methodology. After that, finally, I can get the global equation from the fourth step. I can solve the global equation system with the direct and iterative methods as like our numerical procedure, Newton's Raphson method, likewise lot of method available in iterative manner. So I can utilize that concept for direct and iterative methods can be used for the solution. Final step, what are all the other parameters are involved my component? I consider these things also. For the reason, sixth step is also available with FM, which is compute additional results. For example, in mechanical problems, stress strain curve is available, which are of interest in addition to displacement as like this curve. So I can compute additional results also with the finite element methodology. These are all the fundamental things, fundamental steps that are available with the how to finite element methodology works. Thank you. If you are having any doubts, you may ask me through.